Hi friends, welcome back to our instrumentation series. In this session, we'll study the fundamentals of instrumentation in the form of generalized measurement system and their functional units. So if you see the generalized measurement system, we need to understand what are the basic functional units and what are the auxiliary functional elements, basically. So let's understand this with a block diagram, which these are all the physical parameters which we have. Any physical quantity which are to be measured, we normally call it as measurand. So they can be force, velocity, pressure, displacement, temperature, flow, acceleration, strain, current, voltage, frequency, pH value, humidity, etc. So this is basically a measurand. Now this measurand is given to the primary sensing element. Right, primary sensing element, we can have a secondary sensing element. So if the output of the primary sensing element is not directly given, cannot be directly given to the signal conditioning, then we go for a secondary sensing element. Then after this, the signal is given to the signal conditioning element. Okay, so basically the basic functional elements are those that are integral parts of all instruments. These are typically the transducer element that senses and converts the desired input to a more convenient and practicable form to be handled by the measurement system. Then this signal goes to the signal conditioning element. Now here, signal conditioning or intermediate modifying element, we call it, for manipulating and processing the output of the transducer in a suitable form. Now it can amplify the signal, filter the signal, integrate the signal, convert from analog to digital or digital to analog. So all these can happen in signal conditioning element. Then this is followed by data presentation element, which we are seeing it here. The data presentation element, which gives the information of the measurand or the measured variable in a quantitative form. Now this you are giving it connecting a terminal for some recording, and this is an analog indicator clearly showing. And here you have a digital display. Then you have a data logger for logging the data with respect to time. Then you have a graphical display. We call it as a recorder. And then we have a printed output. So these are all the different forms of data presentation elements that are there in the generalized measurement system. So transducer element, signal conditioning element, and data presentation element are essential for any instrument system. You take any measurement system, these three are going to be the essential elements of the generalized measurement system. So this is followed by auxiliary elements, are those which may be incorporated in a particular system depending on the type of requirement, nature of measurements, technique, etc. You know, some of these could be the calibration element here. Calibration element, it's basically a signal generator to provide a built-in calibration facility of a known input value. So we are giving a known input value through a signal generator and then accordingly calibrating the instrument. Then the external power supply may be required for a calibration element, or it may also be required for a transducer element to a signal conditioning element or a printed data presentation element. So the external power element, some mechanical devices you may not require. That is the reason why this is called as an auxiliary element. Then many of the systems, you also have a feedback element in terms of control systems. So this is the generalized measurement system, which can be very essentially explained as basic functional units in terms of transducer element, signal conditioning element, and data presentation element. Then supported by auxiliary elements, calibration element, and external power element. Okay, so this is a very simple block diagram which you can easily explain any generalized measurement system. Let's slightly get into the details to see what is the thing. So the primary role of the primary sensing element is to quantify the measurement that is made to its first contact with the primary sensing element of a measurement system. Okay, so because the quantity under measurement is what we have seen all the parameters here: force, velocity, pressure, all these things. So these are all the quantity under measurement. These quantities make its first contact with the primary sensing element of the measurement system. Then the measurand, whatever the quantity under measurement, we normally call them as measurand. So is first detected by primary sensing element, giving the output in a different analogous form. The output is then converted into an electrical signal by a transducer, which converts energy from one form to another. That's where the transducer element comes. Then the first stage of measurement system, many instruments, it is also known as detector. Then the transducer stage voltage conversion takes place. This can be a secondary transduction stage. The output of the primary sensing element may be electrical signal of any form, may be a voltage, a frequency, a current, or some other electrical parameter. For the measurement to perform the desired function, it may be necessary to convert this output to some other useful form. Now, this is given to the signal conditioning element that is followed by the transducer element. So the function of the signal conditioning element is to manipulate the signal present to it, preserving the original nature of the signal. That's very important. Okay, some linear or non-linear processes like amplification, modulation, detection, sampling, filtering, chopping, the conversion, data ADC to analog to digital conversion and digital to analog conversion, etc. And these are all performed on the signal to bring it to the desired form that may be accepted by the next stage of measurement system, which is because the signal that is going from the signal conditioning system should be readily represented by a data presentation element. So the data presentation element conveys the information about the quantity under measurement for display, monitoring, control, or analysis purposes. When the elements of an instrument are actually physically separated, then you may require data to be transmitted from one place to another. So these devices may be analog or digital indicating instruments like ammeter and voltmeter, etc. In case the data is to be recorded, recorders like magnetic tapes, high-speed camera or TV equipment, cathode ray tube, printers also may be used. And for control analysis purpose, microprocessor or computers also be used. So the final stage in a measurement system is known as a terminal stage, which is nothing but data presentation element. So all the functional elements basically end up in presenting the data in one form or the other. Anyway, this is just a supplementary thing. We have a physical mass of an object is a physical process, which we normally call it as a measurand. Then this physical variable is given to a sensor, and the signal variable is given to directly the display. Okay, so the observed output, this we normally call it as a measurement. So here itself we have the signal. You don't require much of a signal conditioning. In this case, you are straight away giving the signal of weight to display. Then this is a more refined form what we have seen here. Physical system, all the parameters, input, variable, conversion element, transducer, variable manipulation element, signal conditioning. Then data, you are transmitting the data to a modified signal data processing element. Then you are giving either to indicator or to recorder or a controller. You're also giving a feedback to the physical system, data presentation element. So this is another form of representing the generalized measurement system. Same thing, you have sensor, variable conversion element, basically the transducer, secondary transducer, giving to the signal processing. The output is given, it transmitted to a different thing. You may have an amplification here. Then signal presentation or recording happens here. Okay, so this is exactly what you have a sensor. There are different ways of representing the generalized measurement system, right? And this is only the this is only the different way of how you are representing this: indicator, recorder, computer, processor, or controller. We have seen it in the very beginning, signal conditioning stage. Then if you see the bourdon gauge as an example, because this is basically a pressure gauge. Okay, so where you are putting pressure here, then as the pressure is applied, this tube, which has a elliptical cross section, tends to get circular cross section, because of which it moves. Okay, because this is a closed end, and then this is through a link. This is connected to a pinion and gear arrangement, so that the indicator moves. Let's see it in this. This is exactly what happens. This is slightly the better version, where we have the socket and the thing. you have an adjuster. So when the pressure is applied, this link moves like this. So because it's a gear and pinion arrangement, the indicator moves throughout the scale. And finally, the instrument looks like this. So wherever the cycle shops that we are seeing, where we are inflating the tires, exactly this is the tube Bourdon gauge you will be seeing. And for top, this is how it looks like. We will see only the indicator. But inside, whatever you see, the entire mechanism will be there in that. So this is a purely mechanical form of it, where you don't require any external power supply. Purely we have a, this is a sensing element. This is a signal conditioning element. Then this is a data presentation element. So this is a data presentation element. This is a signal conditioning element. This is the C tube is a sensing element. So we have all the three basic functional units in this. Then if you want to to this mechanical system, to this link, we can connect an LVDT here, which gives basically the connect to a voltage amplifier, then read out directly in the digital voltmeter, for which you require an external power source. This displacement, okay, this Bourdon gauge is converting pressure to displacement, and LVDT is converting displacement to voltage. So this is this becomes the primary transducer. This becomes the secondary transducer. And here you have the amplifying signal conditioning taking place, and then the data presentation taking. This is exactly what is happening here. When you apply pressure input variable, Bourdon tube plus LVDT, they becomes the transducer primary and secondary transducer. Small transducer voltage is given to electrical voltage amplifier. This is a signal conditioning. Amplified signal is given to digital voltmeter, and where you require an external power supply. Okay, so you have an auxiliary element here and basic three functional elements. That's how we understand the. Now then, typically this is also applied to generalized measurement to mercury in bulb thermometer, where you have a capillary here and mercury in bulb, temperature bulb here. So when it is heated, it expands, and this is given to spiral Bourdon tube, which tends to get straightened as the temperature is increased, as the vapor passes through this. So this moves the linear gear to this, and this is connected to gear and pinion. Okay, this is a pinion and this is the gear. And when the indicator is connected to it, you have the pointer moving on the thing. So you have the sensing stage, primary sensing, secondary sensing, signal conditioning, and presentation. So we have that's exactly what we have in this. This is for a mercury in bulb thermometer to understand the generalized measurement system. Similarly, let's understand the vapor pressure thermometer, where we have a sensing bulb. When the vapor is exposed here, this is again connected to your C tube, and this tends to get straightened, because of which the pinion and gear, the indicator moves. So you have the primary sensing, secondary sensing in this, okay, signal conditioning part here, and then the data presentation part here. That's how we normally understand the generalized measurement system. So thank you very much.